Welcome to this video on finding and interpreting the linear regression equation. Finding the regression equation or line of best fit. Please note that the phrase linear regression equation and line of best fit will be used interchangeably in this video. It is possible to calculate the regression equation of a scatter plot by hand. However, performing this calculation manually is very time-consuming and impractical. As a result, in this course, we will be using technology to calculate the equation for the line of best fit, or the linear regression equation. If you are curious about how to calculate the regression equation by hand, there are many instructional videos on YouTube that you can watch. Let's begin with an example. In previous videos, we have used the same example that compares blood alcohol content and number of beers. How much alcohol can one consume before one's blood alcohol content is above the legal limit? To answer this question, an undergraduate statistics project was conducted at The Ohio State University in Columbus, Ohio, that explored the relationship between blood alcohol content and other factors, such as amount of alcohol consumed. Each individual participating in the study was assigned a random number of beers they had to drink. The blood alcohol content of the individuals was measured at 2 different time periods. In this example, X is the number of beers, or the predictor variable, and Y is the blood alcohol content, or the response variable. To better understand predictor and response variables and how to determine them, please watch my video on scatter plots. Next, we want to decide if we expect to have a positive, negative, or no correlation between the two variables. If you want, you can pause this video and make a prediction, and then unpause it to see if you are correct. We would expect a positive correlation between the two variables. In other words, as the number of beers a person drinks increases, we would expect their blood alcohol content to increase. The next step is to use either manual calculations or statistical software to find the linear regression equation. So let's assume that we're going to use some statistical software. So regardless of what we use, we have to look at the output and identify the linear regression equation. So as you can see, it's in different locations depending on which software you use. However, in either case, we're given many digits after the decimal point, so we're probably going to need to round. But how do you know what to round to? Well, in general, you should follow the directions if the directions say exactly what to round to, or you can use your best judgment. In this case, I'm going to round both the slope and the y-intercept to 4 decimal places. So now that we have our linear regression equation, you can see both software packages gave me this in terms of words, right? So instead of putting an X or Y or whatever variable you might want to use, they put in blood alcohol content, or BAC, and beers. So of course you can absolutely keep that there and use it, but most of my students are coming out of algebra, and so they're very accustomed to seeing X and Y in a linear equation. So that I can follow up with that and attach new information to existing information, we are going to replace those words with variables. So remember we said that blood alcohol content is our response variable. So that's plotted on the y-axis. The number of beers is the explanatory variable, which is plotted on the x-axis. Therefore, we can replace the blood alcohol content, or BAC, with the y variable and beers with the x variable. Doing this, we have y equals negative 0.0127 plus 0.0180x. Now we need to identify the slope and the y-intercept of this equation. So if you want, you can pause this video for a second and see if you know which of these numbers is the slope and which is the y-intercept, and then unpause it and see if you are correct. One thing that you really want to be careful of is that the order of the numbers in the equation, the order of the terms, does not matter. And you might notice, you might recall from algebra, we're really used to seeing y equals mx plus b, aren't we? Right? That's what was drilled into our heads. But let's look at what we have here, right? We don't have y equals mx plus b, right? Our x is over here instead of over here. In fact, I could rewrite this equation above, right? I could rearrange my terms. The 0.0180x I could move over here, and the negative 0.0127 I could put over here. So you're going to get into trouble and make mistakes if you rely on the location of these values to tell you what is the slope and what is the y-intercept. So rather than the location, what we want to do is we want to remember that the slope the m of the mx, right, the m in the mx is always the coefficient of x. So now that we know that, again, pause this video if you haven't already done so, see if you can identify the slope, knowing that the slope is next to the x. So if you said the slope was 0.0180, you were correct. And again, notice in the two equations, because they're written differently, the slope happens, it occurs in different locations. So again, be very wary, be careful of relying on the location to determine where your slope is. So the y-intercept is a constant, meaning it doesn't have a variable next to it. So you can say that it stands alone. So what is the y-intercept in this equation? Well, you can probably see it has to be the other number, right? So in this case, the y-intercept would be negative 0.0127. Interpreting the slope. You may recall from a previous class the following definitions of slope. Slope is equal to the change in y over the change in x. It's also equal to the rise over the run. For a more thorough review of slope, please watch some of the videos that I've created on slope. In the problem we just completed, we found the slope was 0.0180. But what does this tell us in the context of the problem? Well, the slope is 0.0180, or 0.0180 over 1. So 0.0180 is the change in y, and then 1 is the change in x. Simply put, the slope tells us that for every 1 unit change in x, there is a slope unit change in y. In this case, for every 1 unit change in x, there is a 0.0180 change in y. If we stopped here, however, that would not really give us a complete picture. What we need to do is we need to put this explanation in the context of the problem, which means we need to add the units in question, which are number of beers and blood alcohol content. In this case, for every 1 beer consumed, a person's blood alcohol content increases by 0.0180. Now let's interpret the y-intercept. In this problem, we said that the y-intercept is negative 0.0127. But this isn't actually the full picture. Remember, the y-intercept is actually a point on the graph. It's an ordered pair. So the y-intercept is actually the point 0, comma, negative 0.0127. Let's add units to this ordered pair in order to help us begin to interpret it. The 0, the first 0, is the x value, which is the number of beers. The second value, negative 0.0127, is a person's blood alcohol content. This means that when a person has had 0 beers, or before they have consumed any alcohol, they have a blood alcohol content of negative 0.0127. Let's pause a minute and think about what that means. Does this make sense in real life? It doesn't, because it's not physically possible to have a negative blood alcohol content. What should the real y-intercept of this equation be so that it makes sense in real life? Pause this video, write down your answer, and then unpause it. In real life, we know that a person who has not consumed any alcohol should have a blood alcohol content of 0. Again, it's not physically possible to have a negative blood alcohol content. At this point, you should now be able to find the regression equation of a data set using StatCrunch and identify and interpret the y-intercept of the line of best fit. When you do this, remember the y-intercept is 0, y, and the interpretation is that when the x variable is 0, the y variable is whatever the y-intercept is. Remember, you have to put this into the context of your problem using the relevant units. You should also be able to identify and interpret the slope of the line of best fit. The formulaic way to express or interpret the slope is to say that for every 1 unit change in x, there is a, whatever your slope is, unit change in y. Again, just writing this answer and inserting your slope is not sufficient. You have to put this into the context of your problem using the relevant units.